Now the point is, the way we run the regression, you can recover everything. In particular, you can recover Pareto weights. And this is, once you do that, you can recover each individual risk aversion up to some common multiplicative factor. So in particular, you have an idea of the distribution of those risk aversions, and you can test whether everybody has the same risk aversion. So that's by village. There are two specifications. Forget about it. It's the log likelihood, the p-square. That's the p-value. So that's the probability that we observe what we observe under the rule that people have identical risk aversion. And when I was saying that's the strongest rejection I've seen in economics, I only have something like 100, 150 observations per village. It's not so easy to get a rejection at the 10 to the minus 83, which is 10 to the 80. It's 1 over a number which is larger than the number of particles in the universe. And this kind of rejection is quite spectacular. Well, simply this tells you the data are screening that people don't have identical risk aversion. And when you look at individual data, you see a lot of them. The response to a same aggregate shock for some household is a lot of smoothing, whereas for other households, it's exactly replicated like this. So anyway, with the right technology, you can address that. Let me skip this. That's very interesting, but I don't have time. Let me just talk about the last extension, which is labor supply. All what I was talking about before was just mentioning resharing in a sort of passive way. I'm hit by a shock and I receive payments. But I can do things. Right? In particular, I can change my labor supply. I could change my consumption structure. There is less of a leeway thing, but I could change my labor supply. So definitely, I would like to look at this. I would also like to look at this because whenever I'm using a marginal utility of income, if references are not separable, the marginal utility of consumption depends on my labor supply. And if I don't control for this, my tests are misspecified. And the good news is that we can observe labor supply at the individual level, which means that it's very hard to go within the village, within the household, in the previous line of literature, because we don't observe individual consumption within the household, but we do observe individual labor supply. So we can go one step further and look at the level of risk sharing which takes place within the household and the level that's taking place across households. Let me skip this. Let me just mention the final thing I want to mention, and then I will give you a couple of results. We're used to the idea of risk sharing when we're talking about income risk. I'll try to convince you on a very simple example that when we're talking about sharing wage risk, things are quite different, and in particular, our intuitions can be completely misleading. Of course, wage risk is very important in practice. In practice, most of the shocks, when I'm hit by a shock, it's not the fact that all of a sudden my social security check is decreased by 50%. It's very likely to be that my wage is decreased by 50%. Maybe not 50, but no, I'm unemployed for 6 months or things like this. So the question is, most of the risk we call income risk is in fact wage risk. But the point with the difference between an income risk and a wage risk is that the income is exogenous, whereas the wage risk triggers a response in terms of labor supply. So even if wage shocks are exogenous, shocks on labor income are endogenous in the sense that they incorporate the behavioral response to the shock. Let me just give you one example to show you that the intuition here can be sort of misleading. Here is my example. I have 2 agents in this economy. One agent is only consuming, and he has a linear utility. So this guy is risk neutral. So that is, here in this model, you might expect that insurance is not an issue because there is a guy who is risk neutral. So efficiency must require that this guy is taking all the risk. Right? So in principle, everything is obvious. That's the particular case. General, those issues of risk sharing are difficult, but when one guy is risk neutral, things are very simple. This guy has all the risk and everybody is completely protected. Well, but now the other guy, he has 2 consumption. He has two commodities. One is consumption, the other one is leisure. So that's the standard, utility. I'm taking a Cobb-Douglas utility, the simplest form with the same coefficient here whatsoever. Okay? And then I'm asking myself, what's the efficient resharing? Now I can compute the efficient resharing just by writing the program and solving it. I'm maximizing the weighted sum of expected utility and I write the first order conditions and so on and so forth. Let me try to test your intuition on this. I give you statements and you tell me whether you agree or disagree with this. Statement 1. The consumption of member 2 should not vary. And by the way, everything can vary here. So I'm interested in wage shocks, right? So essentially there is only one wage here, which is the wage of member 2. So I'm looking at what happens if the wage of member 2 varies. Statement 1. The consumption of member 2 doesn't change. Makes a lot of sense, right? Because there is this guy, member 1, who is willing to fully insure it. In addition, this is a separable utility. If you take the log, it's separable, it's additively separable in the ordinal sense, right? In terms of, so that seems a good candidate for, it's wrong. Actually, when there is a wage shock, the consumption of 2 will fluctuate, despite the fact that there is this guy who is willing to provide all the insurance you want at a fair price. Like that, well, let me just, you can do the computations, and here is what you get. The consumption varies with wage, and this is the coefficient. So when there are fluctuations of wage or fluctuation of consumption, there are fluctuations of labor supply, and there is fluctuation of utility. So my second statement would have been, even though consumption and labor supply fluctuate, utility remains flat, because that's exactly what insurance is about, that maybe I achieve the same level of utility with a different bundle of consumption, but I'm insured, so my utility should be flat. No, even the utility. What's going on here? Well, the point is that's a situation in which you don't want, as person 2, your consumption to be flat, because the fluctuations of your consumption are increasing. Why that? Because whenever you have 2 commodities, there is behavior. Whenever there is behavior, there is a max. And whenever there is a max, we introduce convexity. But convexity means reference formulas. Now, this may sound completely paradoxical, but let me restate it in a way which would sound much more natural. Assume that my wage goes up. I could keep my labor supply unchanged. But that would be irrational. That would be inefficient, not from the ex-ante point of view, but even from the ex-post point of view. When my wage is high, I should take advantage of the high wage to work more. And when my wage is low, I should take advantage of this low wage to work less. But of course, if I'm working more or less, then if my labor supply fluctuates, and I like this labor supply to fluctuate, it's not that my labor supply is forced to fluctuate. It's I'm willing. My welfare would be decreased if I was imposed to keep the same labor supply. I want to take advantage of the fluctuations. Okay? But of course, if my labor supply fluctuates, my consumption will fluctuate. That makes a lot of sense. This precisely describes what's going on, but that makes a lot of sense. Now, what about my utility?